Well, let's see how long that lasts.
Don't get into DME and mine just adds the.
Any questions?
Yeah, could you remind me what the little K with the 20 newtons per meter is?
That is the spring constant.
Okay.
Gives you an indication of how much force is required in order to stretch or compress that ideal spring.
Oh.
That might be important.
Welcome back. And glad you could make it. So since you're wearing a mask, how can we tell if you're actually coughing along or something?
Well, I feel like it would be a pretty big dent.
No. Could be. We'll find out maybe.
Dr. Fox, when's your birthday?
Next semester.
Really?
Yes, really.
When next semester?
What's that?
When?
I'm a Taurus.
You're
What does that even mean?
So, April? Or,
April.
okay, late April, early April?
Well, Taurus should give that away.
It should.
All right, so we have this spring.
Wait, it is late April. I'm done.
We have a 50 kilogram mass sliding down a ramp which has friction. Hopefully my numbers work so that it actually will slide. I'm assuming that it will. And the question is, how much will the spring compress?
Okay.
Well, obviously there is friction, so
Hopefully.
energy is not conserved. So, we start out with work energy relationships. It's been a while, but I'll remind you, non-conservative work is equal to the change in energy. Conservative work is equal to the negative change in potential energy, and total work is equal to the change in kinetic energy. What are the forces acting on the mass?
Friction.
Normal.
Gravity.
Gravity,
Well, gravitational acceleration.
thank you.
Force.
All right, so we got these three forces involved here. Which of these three will be doing work?
Wouldn't it be friction?
That would indeed do work.
Then weight would too.
Yes, it would.
Then wouldn't normal force do?
Would normal force do work?
No, because it's preventing it from sliding through. It's,
From going through the ramp?
yes.
That way, good. And from a math point of view, it's because the normal force is perpendicular to the movement, therefore it doesn't do any work. Work is a product, a dot product of the force times displacement. The dot product multiplies parallel parts. So if two vectors are perpendicular to each other, no work is done. So I have a conservative force and a non-conservative force. So we'll be using the first one there. I know that the work done by friction is going to be equal to the final energy minus the initial energy. Or the initial energy plus the work done by friction is equal to the final energy. And what are the two types of energy that we care about here? What are the two types of energy? And?
Static.
No.
Potential.
There we go.
Sorry.
Go to say it. Somebody want to say that louder?
Kinetic. Mechanical. I don't know what I
Kinetic and potential.
There we go. So we have the initial kinetic energy plus the initial potential energy plus the work done by friction is equal to the final kinetic plus the final potential energy. No, just that. I'm about to ask that question that all of you should know the answer to. What's the formula for kinetic energy?
1/2 mv squared.
Maybe it's just because I was closer to this side, I only heard voices coming from over there. We try that one again. Took his head over here. And it's allergies, in case you were concerned about other things. Coming from back there. All right. What's the formula for kinetic energy?
1/2 mv squared.
Still sound incredibly quiet over here.
We do.
Okay, whatever.
1/2 mv squared.
All right, just this part of the room. What's the formula for kinetic energy?
1/2
So, try that one again. Just this part of the room.
1/2 mv squared.
This part.
Are you referring to me or
No,
not?
no. Here, over.
Okay. They can't get in sync.
1/2 mv squared.
I heard that.
Wow,
Thank you.
I've been going on different.
So I got 1/2. We can go for something more easier to see. Wow. 1/2 mv initial squared plus the potential energies.
Which one?
What's the formula for potential energy?
Which one?
Which one?
There we go. Well, what are the conservative forces involved in this problem?
Wait.
The
And
weight and friction.
friction's not conservative.
No, hold on.
No.
That's
Just
not
wait.
conservative.
Just wait.
And right now, at the start of the problem, it is just weight, but it eventually does hit a spring.
So the weird looking KR thing.
Yeah.
That's just a spring constant.
Oh.
Weird.
What force does that ideal spring exert?
Elastic.
Yes,
I was right!
yes.
Oh my god.
We have this elastic force, which is also conservative. So since I have two conservative forces involved in this problem, I have two potential energy formulas. So what is the potential energy formula associated with weight?
MG. Wait,
That's-
what? No.
The potential energy formula associated with weight.
mgh plus c.
Okay,
Oh, yeah.
so we have M, G, H, the initial, plus some constant, I'll just call it constant 1, if it'll write.
Oh goodness.
It changed color though.
Do you need a new pen? Oh god.
I'm so glad they
They
went
fixed.
to this new board.
Would you like to use the whiteboard?
No. Try it with your finger.
Try just one finger.
I don't think
It was
Wait, is he? Are you on like the wrong thing?
on the wrong thing.
Okay, wait, hit on the pen again.
Pardon?
Hit the
At the
pen
bottom.
again. Like on the bottom, where you
No.
Here to change the colors.
No, not that.
No, the one you tried.
That,
yeah.
well, that was there.
Yeah, but hit it again so you can like maybe make it bigger. Like
Oh. No. Oh, no.
What the heck?
All right, with all electronics, turn it off.
Start it.
Turn it back on.
Turn it back on.
I've been lost.
All right, let's see how long this lasts. So I have 1/2 mv initial squared plus mgh initial plus some constant, which I was gonna call C1. And then what's the potential energy formula associated with the elastic force?
Is it just the spring constant?
No.
Okay.
It's
well then.
1/2 K, change of position squared, or displacement squared.
All right, so 1/2 k delta x. Delta, is that what you were looking for?
Yeah, sorry.
Delta x initial squared
Yeah.
plus the work done by friction. Well, I know that it's gonna slide a certain distance. I don't know how far it is going to slide. I just know that it will slide. And I'm gonna establish that as our unknown. So it's gonna slide a distance x. Friction's acting on it the entire way down. So this will be negative because friction's opposite the direction of displacement. The friction times x.
So friction is negative friction x?
The work done by friction is negative friction x.
Oh.
Is equal to, plus constant 2. Is equal to 1/2 mv final squared plus mgh final plus c1 plus 1/2 k delta x final squared plus c2. Obviously the c's go away. I'm gonna dare to change colors. Alright. What is equal to 0?
It's not acceleration in this case.
Is it
Right, acceleration is not 0, but
Because the momentum. and all that.
acceleration's not in the equation. Pardon?
velocity?
Velocity's not here either.
I mean speed.
Speed.
Oh, wait. No, wait, I lied. Final height is 0.
Why?
Because I am saying that the initial point is at the bottom of the thing. At the bottom of this,
Oh, so because you're safe, as you say so. All right, so
yeah, 'cause
it's
that's.
gonna basically compress to there, so you're establishing h is equal to 0 at that point right there, because modern said so. Sorry, Maram or Maram?
Moron.
Okay.
Dr. Foxman, you just spoke to me yesterday. How did you already forget my name?
That's a matter of where the emphasis was.
That's okay, I'm just kidding.
I tried to get my friend's name right for like a week or two before I finally realized it's not a DT, it's added T.
You know, if everybody would just name the, there's some countries where you're actually, there's a list of names you can choose from.
Yeah, like North Korea.
Germany too, I believe.
Yeah, well they just don't like androgynous names. And I say that because I'm illegal there. I'm not joking. It sucks. My mom did it to piss him off because she's got heritage there.
All right, so
0.
what else is 0?
I mean, M isn't in all of it, so that. It's out.
This term doesn't have an M in it, and that doesn't have an
Yeah,
M.
I said M can't.
Oh, sorry, I missed that.
1/2 K delta X initial, because the initial would be 0.
Because the spring is just sitting there.
Good job,
It's-
Stephanie. So,
Can you pause on any changes for the moment? Because I'm trying to wrap my head around the formula. Because I'm slow like that.
We've got, one more zero.
Is that supposed to be a 1 next to delta x in the third?
That's a
Okay, so that is an I.
Wait, Dr. Fox, what does V stand for if it's not velocity?
Stands for speed.
Okay, so it's speed 0 then initially?
Yes.
I said that earlier.
You said velocity was 0,
And then she said
then I
speed.
said,
And then I said speed, but to be fair, I didn't specify which speed, so that's my fault.
I didn't state it explicitly, on a test or quiz, it should be. It starts at rest. We got one more.
Dang, okay. How the heck?
We're trying to find how much does the spring compress.
Is it final speed because it stops like at the bottom?
Yeah.
Haha.
At maximum compression, the mass should be stopped.
Okay, can we pause there? Can
So
I
we-
say yes?
Taken this formula and we've broken it down into just 3 terms.
Dang.
Oh, that's not an equals as in like this turns into that. That's like this is an equation. Oh, that's why I was confused.
Okay. Now, we have height, which was, oh, I did not give you height because we can calculate it.
Yeah.
We have h's, which is sort of an unknown, because the height changes as it goes, x changes as it goes. We have a couple different things here. We have an h, x, and delta x, and we need to somehow get them in terms of one variable. All right, so let's. MGH initial equals 1/2 k delta x final
Yeah.
Squared.
Can you go to the last screen?
plus
FX.
yeah,
Thank you.
the negative fx. So I have mgh initial minus fx is equal to 1/2 k delta x. What's the relationship between x and delta x? I heard a voice over there, but I couldn't understand anything that was said, so I assume you were talking to yourself or to anybody.
Yeah, I think they're just, are they the same? If,
They are not the same.
oh, cause X is, H is 0.
Oh,
X
wait,
starts
this
here,
X is
delta x
that.
starts here.
Yeah.
Delta x plus 10 equals x.
Did somebody say it over there?
Delta x plus 10 equals x.
Yes. The spring is going to compress a certain amount delta x, and so 10 plus delta x is equal to x.
Ah.
So 10 plus delta x equals x. I'm going to do it in terms of delta x. Delta x is equal to x minus 10. So that is one of the substitution that we are going to make there. What about the relationship between h and x? H would be that distance.
Oh, H is X sine theta.
Yeah.
Which is 53.
I have a right triangle here. My hypotenuse is x. H is going to be x sine of 53 degrees, which we'll just label as theta for right now. And so we have H is equal to X sine theta, and that is a substitution we will make there.
Why is the X sign there instead of, why is X there?
Instead of what?
Why is the X connected to sine theta?
This thing is going to start here and it's gonna go down until it stops. So the hypotenuse of this right triangle is X, that's how far the mass is gonna slide. H is the initial height, which is just the vertical distance here. So the sine of this angle is opposite over the hypotenuse. I feel like I'm missing your question, but did that answer?
Yeah.
Okay. Oh, you can do better. There we go. All right, so we have now mg x sine theta minus, well, what is friction anyway?
It's mu times y.
What's y?
What is y?
Yeah, what is y equal?
Normal force.
Yeah, true.
What do you mean? Negative?
No.
Are you asking the formula for y? That's it?
In this particular problem, for a box on ramp, what's the normal force equal to?
I'm stupid, but that might just be mg.
Opposite.
Not just mg.
It'd be positive, yeah.
Would it be 0?
No. The work done by it is 0, but the normal force is not 0. If the normal force were 0, I think this thing would be in free fall.